How's it going, everybody? In our next DMVPN video, we're going to be taking a look at our next topic, which is going to be DMVPN Phase 2, which will be a IGP or BGP routing protocol modification to allow spoke-to-spoke communication. It's actually pretty easy to do, and there's really not a whole lot that goes with it. So we won't need to disable the crypto on the interface tunnels because the routing protocols will provide us an update saying, hey, this is what's happening. So we're just going to go ahead on the tunnel on specifically just the hub. That's all we need to make a modification for. And what we're going to end up doing is we're going to see a bunch of additional routes come through on the spokes. So the spokes will have reachability to the other spoke sites. So let's go ahead and take a look at this on the spokes real quick, because that's going to be where the major changes are going to come into play. So if we do a show IP route EIGRP, these are the routes that we're going to see, that we see currently, right? Everything coming from the hub, everything, all this stuff right here is hub related traffic and local traffic. So now, same thing with CSR5, show IP route EIGRP, we see a bunch of hub traffic. And on CSR6, we see a bunch of hub traffic, right? Well, if I go to CSR3 and I show run section EIGRP, in order to allow this communication to occur, one of the things that I have to go do is I have to go underneath the tunnel interface and I have to disable split horizon on EIGRP. Because what's happening now is when routing updates come in from all of the spokes, it could be one spoke, it could be 100 spokes, doesn't matter. When EIGRP receives the update in on a particular interface, and this is a distance vector routing protocol specific issue, whenever the router receives updates on a particular interface, it won't send those updates back out that same interface. So what will end up happening is we'll have to actually go in underneath the tunnel interface and disable split horizon to allow those updates to be received in and sent right back out. So basically they're going to be hairpinned. So what I'm going to go ahead is on EIGRP, I'm going to just come in here to this level, type in AF interface, is going to be tunnel 100. And then we have this no split horizon, and hit the enter key. We're going to see a resynchronization come through on all the devices. And on router 4, we see this resync come in through. If we do a show IP route EIGRP, we're going to have many, many more additional routes. And they're all going to have the same next hop IP, right? In other words, that's going to be basically how we look at this. Everything's going to be pointing towards CSR3. Now, what I'm going to do is I'm going to do a debug crypto ISA SA and debug crypto IPsec. Yeah, so I have keep alives and stuff like that running. No big deal. One of the things that we're going to see, let me go to up here and type in no service timestamp debug or log. One of the things that we're going to need to do on our config is in here we have these addresses. We're going to need to either configure a new address per spoke that we want to peer to. So if we want to talk to router 5, we'd actually have to add in here another crypto ISACamp key that matches router 5. Another way to do this would be crypto ISACamp key, and the address is going to be key Cisco, and then the address is going to be all zeros. So we need to say, you know what? I don't care what the address is. Just allow it to go. So do show run section crypto, and we're going to have an all zeros entry. So let's just go ahead and grab that command right there. We're going to take this on all the other connections, and we're going to do that on 5 and on 6 so that we have at least that connectivity going. So I'm just going to do a quick show IP route EIGRP, and you're going to see that we have a lot of routes coming through, right? Now the next thing we need to go do in order for all this to work is I'm going to go ahead from CSR8, I'm going to do a show IP route VRF S4. So now we're going to have a bunch of routes for connections on CSR8 already, but they're going to be in different VRFs. So one of the things that I have here is I've learned of the 192.168.60 network, which is coming from CSR6 via gig 1.4. So what will end up happening is CSR8 will send this traffic out inside VRF S4, or I'm sorry, in this case here it would be, yeah, S4. I can go and trace route to myself, because I can say, for example, I'll give you an example of what I mean. I can do a trace route to, and I want you to pay attention to 4 and 6 when these pop off, because what's going to end up happening is I'm going to have to build a connection to that through NHRP, or I'm sorry, through DMVPN, but it won't be through NHRP resolution. So I'm going to do a trace route VRF S4 to, in this case here, I'll do to 172.26.0. So it'll be 172.26.0.8, sourcing from my local loopback right here. And I'll say numerically. So I'm going to go ahead and I'm going to send this traffic out. And what's going to end up happening, source loopback. What's going to end up happening is that traffic is going to go out to 4, go up to 3, from 3 down to 6, and then eventually down to 8. If I do this trace route again, you'll notice that it continues to go through the hub. So it's hub based. It's going to be always going to go through the hub. Is this going to be spoke to spoke? Well, yeah, it is, but not direct hub spoke to spoke. Where here we're having to hairpin through the hub. So all traffic will have to go through the hub and come back down. This is phase 2. Now, one of the key things that I want you to understand about this is if you want to allow, I mean, if you have a, for phase 1, if you have a use case where you need traffic, you don't want any traffic going spoke to spoke, which is a very common design in certain environments. I've had to set that up before where the traffic doesn't go spoke to spoke. I leave it DMVPN Phase 1. They just want to have a large, easily deployable VPN solution. DMVPN meets that need. Where if they want to take it to the next level where they want to go spoke to spoke, but they still have a compliance need where they want to have traffic go through the hub for firewalling or whatever the case might be, they can still do that. Now, is there crypto between the connections? Well, it's still crypto, right? We go up CSR4, we ride a VPN tunnel to CSR3, we get hairpinned back out CSR3 to CSR6. So there is crypto on both ends of the connection. Going from 4 to 3 and from 3 to 6, there is 100% crypto involved. We have to ride over a VPN tunnel. Now, one thing that's commonly misunderstood here about this whole situation is undebug all, is one thing that I want you guys to be aware of here is for every one of these red lines going down to one of the spokes, there are 2 SAs. One outbound, one inbound. So we do a show crypto IPsec SA, type include peer and PKTS. We're going to have connections coming in and out. So we're going to have an outbound SA and we're going to have an inbound SA. When we do, that's from CSR3 to CSR6. We're going to have an outbound SA and an inbound SA to router 5. We have an outbound SA and an inbound SA to router 4. This means that we have 2 encryption tunnels, one going out, one going in, to allow encapsulation and decapsulation, or encryption and decryption on a per spoke basis. Now, multiply that by 50 spokes, that's 100 SAs, one in, one out per peer. Multiply that by 100, that's going to be 2,000, 3,000, depending on how many spokes you have. Always take that and multiply it by 2. So that's going to be one of the limiting factors for this design, is how much crypto you have. So one of the solutions that I've come up with in the past is to migrate off of like a CSR1000V or an ISRG2 and switch over to an ASR1000 series platform where they have a dedicated hardware-based encryption module which takes care of that for you. So you still have massive scale, but you're not relying on the CPU to handle that. You're relying on a dedicated hardware module to do it for you. So those are just some of the things to keep in mind. So it is spoke-to-spoke communication, but you notice it was just writing protocol modification. We had to disable split horizon and things like that. So that's basically what I wanted you guys to see in terms of how all this stuff comes into play and works. So it absolutely does work. If we were to go take a look at CSR8 again, do that trace route, and look back at CSR3 and look at the PKTS, you would see a number of packets to be sent back and forth. So from 4 to 6, we have an increase. Let's go back to CSR8 and we'll do a very large ping real quick. Let's do ping to, and we'll do a repeat of 1000, for example. Let's look at the numbers we have currently. These numbers on 6 and 4 should climb up dramatically. So we go back over here to CSR3, we're going to see those numbers start to climb rather dramatically because we're sending and receiving traffic over it. And does it take a little bit? Yeah, it does. But you can see that the traffic is working the way that it's supposed to. Now we're well over 500. Now we're in the 600s. And after just a couple of minutes, we'll be in the 700s here in just a moment. You can clearly see that 5 is just sending EIGRB hellos back and forth, and they were being encrypted. So that's basically what I wanted you guys to see. We sent about 500 pings. All of them were successful, and we were able to see how that traffic was still being encrypted, going in and going out. And that's the major thing here. You want to be able to validate that, and that's how you would do this. So with that being said, that's how Phase 2 works. So really no debugs needed or anything like that. You might be wondering, well, why did I enable the debug on CSR4? Well, I wanted to show you that this isn't a direct spoke-to-spoke connection. It's going to be a spoke-to-spoke connection, but through the hub. So remember, Phase 1 is spoke-to-hub and hub-to-spoke, but no spoke-to-spoke communication at all. Phase 2 is spoke-to-spoke communication through the hub. So the hub hairpins all of that. With that being said, ladies and gentlemen, I'd like to thank you guys for hanging out with me in this video. And until next time, guys, take it easy.